Hello students, welcome to my channel. In our previous lecture, we have discussed about NCR and NPR and various problems of NCR and NPR. So in this lecture, we will be going through more problems of NCR and NPR. So as I discussed that we will be discussing more problems that are useful for the JEE preparation. So here I am with one more problem. So first of all, read the problem. There are 12 points in a plane, no three of which are in the same straight line, except 5 points which are collinear, and the total number of triangles that can be formed with the vertices at any three of these 12 points. So before attempting this question, we will be revising about the NCR. So what do NCR is used for? Do you remember for what purpose do we use the NCR? So as we discussed, like if there are n distinct objects are given, so to make the groups, like group of R size, like R size group we need to make. Okay, so R here is how many groups can be made? So R is 3. This one it is also possible. This one is also possible. This one group is also possible. This one is also possible. Similar manner, this one group is also possible. And also O1, O2 with ON is also possible. O2, O3, I would color it with a different color, then it would be easier for you to understand. Like there are many groups possible. Okay. So first of all, this one with the orange one, first group. Then I will use the color brown one, this one group. Then again, I use a pink color, then is one more group possible. Okay. Then again, apart from, we can use the color another one, let's say lavender color. So one more group, this one. So okay, in this manner, many groups are possible. We can say there's one more group, let's say using this color, one more group is there. Apart from those, uh, some these kind of groups are also possible. Like if I say O1, O2 with TON, okay, and I can say more groups like this one. If I say O2, O3 with the ON, two elements are here, one element is here. Here all the three are together. Here O1, O2, 3 are together. Here O2, O3, O4 are together. Here O3, O4, O5 is together for this group. Okay. So in this manner, I would say there are many groups possible. Okay. This is G1. Other group with O2, O3 and O4 is a G2 group. And O3, O4, O5 makes another group which is the G3. And other group using O4, O5, O6. The other group, that is G4, and one more group with the O5, O6, and O7. I can say it's a G5 group. And if I have the elements like O1, O2 with the ON, so I have a group that I can say G6. Some elements of star here, some elements of G6 star here. G6 star also your ON also O1 also element. Okay. And if I say another group that is painted by the green, then this is a 7 group. So in this manner, we can get many groups. Okay, so many groups are possible. This for finding these number of groups to simplify the complications, we use the formula. We use the formula, that is, to simplify these complications, we use the formula that is nCr, where n is the total number of distinct objects, n is the total number of distinct objects, and r is the size of group. Let's say here size is 3. So we are grouping n objects into 3, 3, 3, 3, 3, or like consecutive 3, consecutive 3, consecutive 3, or the end 2 element and one element from the front, middle 2 element and one element from the end, middle 2 element and one element from the end. So in this way, many groups can be possible. So to find these number of groups, how many groups? As many as our element can accommodate in this n number of objects, the number of groups can be created. So like we have drawn here, like G1 created G2 group, G3 group, G4 group, G5 group, G6 group, two front element and one back element. In this way, G7 middle elements and many other, like here also two elements from here and one element from here. These two keeping constant and having O4 with them, keeping these two constant, having O3 with them. So there are many groups possible. Okay. But once when we find the count using this formula, here we treat O2, this group and this group and this group as similar groups. Okay, like O1, O2, O3, O3, O2, O1. Like I selected O3, then O2, then O1. Or I selected O1 first, then O2, then O3. Or I selected O2 first, then O3, then O1. All these are treated as one. So remember this point, this is a very, very important point, that in nCr, order do not matters. Like if it is O1, O2, O3, O3, O2, O1, or O2, O3, O1, these are all counted as one only. So number of groups will not be 3 times here. Only one will be. But in NPR, count increases because these are treated as different. It increased by r factorial. So NCR to r factorials becomes the NCR. So this we have discussed in our previous lecture. Now, please try to understand the question and how what we can apply solve this. I hope you understand this point and we have previously discussed, so I revise this concept because it will be important in this question also. So let's see here. What is the question? There are 12 points and in a plane, no three of which are in same straight line, except 5 points which are collinear, then the total number of triangles that can be formed with the vertices at any three of these 12 points. So basically here question is asking like 12 points are in plane. There's a plane, uh, okay. There's a plane, 12 points are there. Okay. So 12 points are there. Let's take three cases. Like you need to answer me that which scenario is yeah, implied in this question. Okay. Like 5 points are in line and other 7 points are like this. Three, four, 5, 6, and this seventh one. So this is a one scenario. Okay. This is one scenario. And other scenario is like this, like all are random. 1, 2, 3, 4, 5 are random and 7 are in line. 2, 3, 4, 5, 6, 7. Second scenario. And third scenario, it's random. Four, 5, 6, 7, 8. So these are all random points. No 3 points are collinear. Collinear means 3 points or more than 3 points lie in a same line. So in this case, no 3 points are in same line. All the 12 points are scattered. Okay. All the 12 points are scattered. All the 12 points are scattered. In this case, 7 are collinear and 5 are scattered. And here, 5 points are collinear and 7 points are scattered. Here, 5 are collinear. Here, 7 are collinear, and either no is collinear. 0 point is collinear, and 12 are scattered. So, please try to understand which scenario is implied in this question. Like 12 points in a plane, no three of which are in same straight line, except 5 points which are collinear. 5 points are collinear. Otherwise, no three of which are in the same straight line. Means 7 are scattered and 5 points are collinear. Okay. So 5 are collinear and 7 are scattered. So I should say that in this scenario is implicable. Okay. So we need to find now the total number of triangles that can be formed with the vertices at any of these 12. Before discussing about the 12 and more collinear points, let's think about the intuition that can be used here. Okay, so let's think about it. So, like, if I want to draw a triangle out of many points, then how can I draw a triangle? So, to draw a triangle, I need three points. So, out of any points, I need to choose three-point groups. So I have 12 points and I want to find the number of count of triangle I can draw from those 12 points. So I need to make group of three points. I have 12 points, let's say. So as many as group I can make of 3 points from the group of 12 points, that would be the number of triangles. But here's a twist. Like if the points are collinear, then they do not make a triangle. Like if 3 points are non-collinear like this, they will surely make a triangle. But if they are collinear, they will not form a triangle. That is a twist here in this question of JEE main. Okay. So if this is the scenario, like if all the 12 points are scattered, so can you get an intuition like there are 12 objects and I need to select three of them as a group, and in this way how many group I can make? So which formula is used for that? N is 12 and R is equals to 3. Three object group need to be made out of 12 object. So how many these kind of three object group can be made? So for that we have previously discussed 12C3. This is the formula. But if you see here that 5 points are collinear and collinear point do not make a triangle. So will it give the answer same as 12C3? I would say no, because because all those triangles that are made by the collinear point will not contribute to the answer in this scenario. So I will subtract those triangles. So how many triangles I need to subtract? Out of 5 points, how many triangle I can make? Out of group of 5 points, I need to select three groups. So how many groups I can select? Here R is equals to 3 and N is equals to 5. So I will subtract 5C3 here. So this will be the answer. So for this, one doubt is always in the student's mind that, sir, why do we not use NPR here? Why do we not use NPR here? So for NPR, if you think NPR, I would give you that little difference. Like if you say there are 3 points, 1, 2, 3. I have selected these 3 points as a one group. And in similar way, if I select 2, 3, 4 as a group, 2, 3, 4, then that will contribute to a triangle. 1 to 4 is also contributed as a triangle. 1, 3, 4 is also contributed as a triangle. So any 3 point can be chosen. But what you see that 1 to 4 or 4 to 1 will result in a different triangle? I would say no. So order is not a matter here. If I select 1 to 4 or 4 to 1, that will give me a same count. So order is not a matter here. That means that I need to just group three points, and I need to find as many as groups I can make. So that will be obviously giving me the answer for the number of triangles. I hope you understand this point. So that is why we are using the nCr. But I will also give you the scenario where we can use the nPr. But always remember, in the case of the triangles from the points, there's always a simple formula, and nCr will always be used. nPr will never be used. We will use never. nPr will be never come in use. nPr will never come in use. So if I say that nPr will come in use in the scenarios like this, like if I have three chairs. This is A, this is B chair, this is C chair. But if I say that I want to arrange 12 people on this chair, like 12 people, let's say one is Ramu, Sonu, and Golu. So Ramu is sitting here, and Sonu is sitting here, and Golu is sitting here. In one scenario, Golu is sitting here, Ramu is sitting here, and Sonu is sitting on C. In one scenario, Sonu is sitting here, Ramu is sitting here, and Golu is sitting here. So in this case, if you see that these all three are resulting in a different arrangement. So whenever arrangement kind of question, like 12 people need to be arranged on 3 different chairs. Okay, so arrange kind of questions, you use the formula of nPr. Here 12 P3 number of arrangement would be possible. But in the questions of the triangles, you always use the C3 formula. Okay. So I will give you a simple trick to solve this question in 5 seconds. So whenever you find that total number of points are given and some collinear points are given, and you need to find the number of triangles. So simply just check the count of the collinear point as well as total number points. That will give you the answer in 10 seconds. This was the explanation I gave you to simplify and to understand the concept. Otherwise, in the question in JE, you just need to use this formula. Okay, so formula is nC3 minus mC3. That's it. So n is the total number of points, and m is total number of collinear points. Okay, so n is the total number of points and m is the total number of collinear points. Okay, so in this way you will get the total number of triangle that can be formed, triangles that can be formed using n points in which m is collinear. Okay, so that's enough for the today's class. I would say one more concept is important regarding it. So here 12C3 can be calculated. Like 12C3 is 12 factorial, 12 minus 3 factorial upon 3 factorial. So it can be calculated as 220, and 5C3 can be calculated as 5 factorial, 5 minus 3 factorial upon the upon the 3 factorial. So in this way we will get 10, and the total number of triangles would come as 210. So I would tell you in visualization also, so that you can realize this formula and you can just blindfoldedly use this formula like nC3 minus mC3. Okay. So if I say that I have no collinear point, so here 0 comes. So I should get the answer nC3. Okay, let's confirm this formula. Like if I have 4 points like this, in which none is collinear. If you say no 2, 3 points are collinear, these two are in same line, but these two are in different line. It is not coming on this line only. Okay. If these 2 points are in one line, but these other 2 points are not in line. If these 2 points are on line, okay, then other 2 points are not in line. In similar manner, these 2 points are on same line, but other 2 points are not lying on this line. So no 3 points are lying on same line. So there's no collinear points here. No 3 points are collinear. So if no collinear points are there, like 3 or more than 3, 4, 5, no 3, 4, 5 points are on same line. So here m becomes 0. Here m becomes 0. So if you see how many triangles can be formed. So 1, 2, 3, one triangle, 2, 4, one more triangle, 1, 2, 4, one more triangle, and 1, 3, 4, one more triangle. So 4 triangles are possible. So using the formula, let's put the value total number of points are 4 here. So using 4C3, we will get answer 4. Let's check for the this formula for the collinear points as well. Okay, let's have one three collinear points. Okay, so let's think how many triangles should I get? Like one, two, three. After joining one, two, three, one triangle. One, three, four, one more triangle. Okay, one, two, three, one triangle. One, three, four, one triangle. And one, two, four, one more triangle. So only three triangle I will get. So what happened here? Here also there are 4 points, but what happened here? It is that there are three collinear points. So 4C3 minus 3C3 comes in the picture. So that's why 4 minus 1 angles are received. So in this way, we can confirm that this formula works best. Like if m number of points are on same line and n points are scattered. Okay, these are not collinear. These are collinear, these are non-collinear. Then you can use the formula nC3 minus mC3 for the number of triangles that can be formed using those points, where n are the total number of points and m are the total collinear points. So thank you for the class, and I hope this question uh, will help you in understanding more problems like this, and I hope you get a good score. Thank you.